Hello, everybody, and welcome to the presentation of CBG 105. So, this is the website of the project. Let me walk you through it. Here we've highlighted some of the steps of the process, so analysis, stage analysis, and then results. Here we've highlighted some of the pros of the project. Here we've given the user an option to either register or log in. I'll come back to that later, but let's just scroll down for now. Here we've given the user an option to get in touch with us. So let me show you how this works. I type in my email, and for illustration purposes, let's just say I type in a message like hello, and I send it. This is the admin side of things. From here we can access the database side of things. And from here we'll go to contact, and there, as you can see, the message has arrived. I click on the message, and as you can see, the name, the email, and the message. So that's how admins can access that.
Hello everyone, I will now be explaining the workflow of our project. First, we created a model for DR detection using machine learning, convolutional neural networks, as well as image preprocessing. Then, when we created this model, we uploaded all our retina fundus images onto this model. This was done for primarily two purposes. First was processing the image data itself, which included scaling, cropping, things like that. And the other purpose was to train the model to detect as well as classify these images into DR and into various stages of DR. Once this was done, then we pass our customer data onto the training model, which is the data that we've received from the website. Then once our trained model processes these images, then it generates a predicted output, which is on the basis of the data that it already has and the processing that it's already done. Then on the basis of this predicted output, we decide whether DR exists or not, or which stage of DR is the patient in. For example, if the output is 0, then we say that there is no DR, or the eye is normal. If the output is 1, then we say that there is a mild NPDR. If the output is 2, then we say that there is moderate NPDR. And if the output is 3, we say that there is severe NPDR. And if not even that, then it is proliferative DR. So this is how we're able to kind of process the retina images of the person that's logging on our website and give them a comprehensive solution as to which stage of DR it is and whether DR itself exists or not. Thank you.
There are two existing methods to tackle the problem of diabetic retinopathy: fundus photography and automated traditional works. However, if we apply CNN in this field, then it would benefit a lot of people, as it would be a cost-effective as well as quick method to detect and further manage the disease. The dataset used here is a large set of retina images taken from the 2015 Diabetic Retinopathy Detection and Aptos 2019 Blindness Detection competitions. Each image has been resized and cropped to have a minimum size of 1024 pixels. DR can be classified into 5 stages: 0, 1, 2, 3 and 4. 0 is no DR, 1 being mild, 2 is moderate NPDR, 3 is severe, and 4 is proliferative diabetic retinopathy. Since the dataset was very large and unbalanced to process, so we balanced it out by taking 900 images from each class, which makes it a total of 4500 images in the dataset. The major challenges faced after importing the data is to process it and make it suitable for training. So this includes handling of the missing data, if any, categorical values, textual values, spelling errors, and image processing. To ensure that the machines learn the true features of DR rather than device-specific information, we need to process the acquired fundus images from different sources and change them into a uniform format through the following steps. So the first would be size normalization, where the final obtained image has dimensions of 128 into 128 pixels. Then noise filtering, where the Gaussian blur filter is applied to enhance the features and reduce noise in the images. Scaling is performed to enhance the images which have a very dark contrast overall. And finally, data augmentation is done to mitigate shortages in the data and fully utilize the data that is available. The dataset is split in the ratio of 90:10 for training and testing respectively, and then 20% of the training data is used for the validation purposes. The model built here for developing this project is based on the sole knowledge of neural networks, and the model used is VGG16. We have achieved an accuracy of approximately 70%, and the project is deployed for anyone to use. Let's now have a look on how the user will check their DR detection results on our website.
This is Kunal Gupta, and till now what we have actually understood is that a user needs to be logged into our website in order to actually upload a fundus image. Also, we have seen about the flowchart of the DR system, and also we have some brief idea about the DR system as well. So here I'll explain you about what a user needs to do after he or she has logged in into our website. So they simply need to actually upload the fundus image. So let's upload an image. So let's actually rename this image firstly. So let's suppose, okay, let's see, okay, and let's upload this image. I'll tell you why I've renamed this image. So let's see the result. What are the results? So okay, the results are, these are the results. So first is the upload image that we have uploaded. Second is the pre-process image. That means all of the pre-processing that has taken place onto our actual image. This is the final output of it. And this pre-processed image is actually passed onto our CNN model. And after this, after the calculations done by the CNN model, it predicts that the stage is moderate. Now I'll show you why I have renamed this image. So let's see, the name of the image was K. Let's see whether it's uploaded into our database or not. So let's do so. So let's see ML models. So we see that this is the image k.jpg. So we see that the image is also getting uploaded into our database as well. Overall, the accuracy of our model is 70%. And some of the benefits regarding this is that firstly, it is really cost effective. Secondly, it is highly accessible from any part of the world to any of the diabetic patients as well. So these are some of the benefits of our model. Thank you.